Let's look at some acid-base equations now. All acid-base equations are also double displacement reactions. So let's start with the first one over here and work with sulfuric acid, H2SO4, aqueous, plus calcium hydroxide. Okay, also aqueous. So the first thing we have to do is predict the product. So again, double displacement. Okay, so let me go ahead and do that here so that we can save some space for writing the equation out. Okay, so H2SO4, we have to dissociate that, and so we have H plus, okay, and SO4 minus, 2 minus. Again, don't worry about the 2 yet. Okay, we're going to do that in a few minutes when we balance the equation out. So calcium, 2 plus, and then we have hydroxide, okay, which is the OH minus. Those are the key ions, okay, that we have. So remember, for double displacement, you have to take the cation of one and the anion of the other, and then take the cation of one and the anion of the other, okay, and form the compound. Once you do that, calcium will give you calcium sulfate, and H plus and OH minus will give you water. Okay, so those are the products that you should be expecting. So let's go ahead and write what we call then our molecular equation. Okay, we will always be writing these 3 equations. So molecular equation, ionic, and then net ionic. So here is our molecular equation then, H2SO4 aqueous plus calcium hydroxide aqueous to give calcium sulfate. And calcium sulfate, we'll just wait a second over here, and then we have H2O. Okay, calcium sulfate, sulfates are going to be solids. Okay, so here's our solid, and water of course is a liquid. Remember, it's not aqueous. Okay, so then we write our ionic equation. Is our equation balanced? What do you think? Not quite. Alright, so we have the calcium sulfate, which is fine, but the water is not balanced out, so we need to put 2 waters, okay, over there. Alright, ionic equation then. So we dissociate the H2SO4 sulfuric acid. Now we put the 2H plus over here. Remember, no H2, okay? This is not happening, alright, so don't write that at all. SO4, 2 minus, aqueous, plus calcium, 2 plus, aqueous, plus 2, hydroxide, aqueous. And again, don't write this, okay? This is wrong. Please do not do this, okay? That's absolutely wrong. And then in your product side, we don't have any ions. So calcium sulfate, solid, plus 2H2O, liquid. So in this case, our ionic equation is also the same as the net ionic equation because we have no spectator ions. Okay, so now let's move on to the next problem. All right, another acid-base equation. So now we will go ahead and take aluminum hydroxide plus HCl, hydrochloric acid, aqueous, and let's figure out what the products are going to be. Again, we can write it out. So aluminum is 3 plus, hydroxide is minus 1, HCl is H plus, okay, and then chloride is minus 1. So crisscross, all right, and this gives us H2O, and aluminum and chlorine gives us aluminum chloride, okay, over here. Now writing our molecular equation, we have aluminum hydroxide, OH3, that's a solid, plus HCl, aqueous, to give us aluminum chloride. I like to write my salt first, okay, and aluminum chloride should be dissolved in water, and then we have H2O, which is a liquid. Okay, aluminum chloride should be soluble. Okay, so once we have this, then we go ahead and write out the balanced equation. So let's see if our equation is balanced. No, we need 3 of HCl to get the chlorine, and then we have 3 and 3 of water, so we need 3 of water over here, 3 HCl and 3 of the hydroxides. Okay, so now our equation is balanced. Now let's write the ionic equation. Aluminum hydroxide solid plus, and we have 3 H plus aqueous plus 3 chlorides aqueous to give us aluminum 3 plus aqueous plus chloride, and we have 3 of those aqueous plus 3 H2O, and that's a liquid. Okay, and again let's see if we have any spectator ions. We do this time. So we have chlorides as spectator ions, so our net ionic equation is then aluminum hydroxide solid plus 3H plus aqueous, and this gives us aluminum 3 plus aqueous plus 3H2O liquid. Okay, so that is our net ionic equation then. So let's write one more, okay, and then we'll be done. This one I'm going to do a little bit faster, okay, because hopefully now we are a little bit more comfortable with writing equations. Okay, so let's pick one really quick. So let's take potassium hydroxide, and we'll write it with sulfuric acid. Okay, both are aqueous. I'm not going to work out as I did before with the double displacement, because hopefully now you can follow it through with me. So we have potassium combining with the sulfate. The sulfate is 2 minus, so which means I have K2SO4. All right, and then the OH is going to combine with the hydrogen, okay, and give me water. Now all I have to do is balance my equation. I have 2 potassiums on the right hand side, and so I put 2 in front of potassium, and then for water I will have 2 hydroxides on the left sides and 2 hydrogen here, so I need to put 2 on this side. Potassium salts are all soluble in water, so I have aqueous, and then water is liquid. Okay, so this is my molecular equation. Now I'm going to write my ionic equation. It's going to be 2K plus aqueous plus 2 hydroxide aqueous plus 2 H plus aqueous, and then the sulfate ion aqueous to give 2 potassium ions, which are also aqueous, and then sulfate 2 minus, also aqueous, and then 2 H2O, and that is a liquid. Okay, then for my net ionic, I will go ahead and cross out my spectator ions, so potassium, potassium, and then sulfate, sulfate. And I have 2 hydroxides, aqueous plus 2H plus aqueous to give me 2 molecules of water, liquid. For most typical acid-base equations, this should be your net ionic equations, where you have the hydroxide and H plus, okay, or proton to give water. That is a typical net ionic equation for acid-base reactions.